So if you try to look up a formula for this stuff online, you're going to see a whole bunch of things. It's going to be confusing, and you're not going to really be learning anything about it because you're just going to be trying to memorize and sift through the right formulas. So just focus on the main ideas of an ellipse. An ellipse has a major and a minor axis. The major axis here is the horizontal axis because this one is longer than it is wide, right? And it's also got a center. And so if you start with those two things, then we can work our way to find out these weird things. The eccentricity and the directrix are the two other big things that we want to know. Okay, let's start with those things with this graph. This is x plus 2. The standard form of a circle and ellipse always has minus baked into the formula. So this is a negative 2 for the center. So negative 2 on the x. And then this is a positive 4 for the y because it's y minus k in the formula. So negative 2, positive 4. This is the center. And then the major axis is going to be the y-axis because the number under y is bigger. And we need to write these as a squared number. So I think that's 13 squared, right? So what that tells us is that we can go 13 units below our center and put a dot, 13 units above and put a dot, 5 units to the left and 5 units to the right. And there we go. We've got the graph of our ellipse. Now that we got a rough sketch of the graph, the major axis is the y-axis. So the foci or the foci, I think I've had teachers pronounce it both ways, are these red dots here. And so that means the directrix is going to be a line in the opposite direction. Because the directrix is always on the opposite side of your curve as the foci, however it is. If we can figure out this distance from the foci to the vertex, then we'll be able to figure out the equation of the directrix because the directrix should be equal distant. This distance should be the same as this distance. Okay. So if we look through our formula, they have h minus a, then times e times k. So we need to know what e is in order to find out the foci. And so it's given here in either this formula or this formula. So to know which one we're going to use, I think when whatever website pulled this from the y-axis, they mean the y-axis is the major axis. So that means we want to use this one. So e, the eccentricity, is going to be the square root of a squared. It's going to be 5. A is always the number underneath the x, and b is always the number, subtract 13 squared. Oh no, it's got to be the other way around. I wonder what this website means by y-axis then. Oh, and it even says b up here too. So look, it has to be the other way around because it was about to get imaginary numbers. Right? So that's one easy way to keep it straight. 13 squared minus 5 squared all over 13 squared. Because it's got to be whatever your a is, has to be down here. This will give us our eccentricity. Then we can use that to calculate the foci. So 13 squared is 169, so we got 169 minus 25 is 144, and the square root of 144 is 12, so we got 12 over 100. Oh, sorry, it's not 13 squared on the bottom, it's 13. And so now we're ready to find the foci, and I guess since we got the formula right here, we could just skip right to the directrix. I'm still confused about this. The y-axis. Oh, it's because they switched the a and the b. So it is this formula. This is the major axis, so we're going to use the y-axis. The foci have to be y equals something. That's how I knew it couldn't be this formula, right? These are horizontal lines I drew. So we need k. So in the standard form of ellipse, it's x minus h. X minus h. And then it's y minus k. So our k is 4. We need a, which if you look at the formula they've rewritten as, 13 is their a. And we need to know e. We need to divide it by e. So if we put all those things in, k was 4. And then it's plus or minus. A is 13 in this case. Because our a is 13. Get rid of that circle. And we divide that by e. Divide that by 12 over 13. So we'd flip and multiply. So this is 4 plus or minus 13 squared over 12. So getting common denominators, that's 48 plus 169. So that's 217 over 12. Once we do it once for plus, and then 48 minus 169, that's negative 121. And those look about right. So when y equals 217 over 12, that looks to be this graph that we originally sketched, so that's matching up with what we expected. And y equals negative 121 over 12, that looks to be about this graph down here.